This is a complicated moments question. It's about as complicated as you're going to be asked to solve. We are going to use moments and the principle of moments to find some of the forces on a body in equilibrium. So I'm told that I have a ladder of length AB resting on smooth horizontal ground against a vertical wall. I am told that the mass of the ladder is 20 kilograms. I know that the mass acts from the centre of mass, so I know the force is its weight. I know it's going to be mg. I'm told that it's an angle of 60 degrees with the horizontal. I'm also told that there is a force P newtons acting horizontally, going that way, at the base of the ladder, stopping it from slipping. And I'm asked to find the reaction forces at the wall, at the ground, and P. So, start off by marking on the reaction forces. They're always at 90 degrees to the surface. So I can mark those just like that. Then I'm going to call this one RW for reaction at the wall, and this one RG for reaction at the ground. I'm also told this ladder has a length AB. So I'm going to mark A and B on the diagram like that. Right, so in order to solve this, I'm going to take moments around a couple of different places on the ladder. So because B is looking like the most complicated one at the moment, I'm going to take moments around B, and that means that I can ignore both RG and P for the time being. There's a couple of things that I need to do in order to take moments around B, and that's resolve the forces on the ladder so that they are perpendicular to the ladder. So I'm going to mark this on for the perpendicular force of the weight. I'm going to mark one on up here at 90 degrees to the ladder for the perpendicular force for the reaction force. So, because I've got a right angled triangle here, I know if that's 90 and that's 60 degrees, that must be 30. So I know that this angle here must be 60 degrees, because 30 plus 60 is going to make my right angle with the ladder. I know from GCSE maths that this Z shape here forms an alternate angle, which means that this angle here is 60, meaning this angle here must be 90 minus 60, which equals 30 degrees. So those are my only two forces on the ladder, which means that I can take moments around B. And I can say that the clockwise moments, so the moments clockwise, are going to be equal to RW. I'm going through an angle here, so it's cos you go through the angle, RW cos 30. And I know that the distance that this thing acts over is the entire length of the ladder, which is AB. So I'm going to write that as AB cos 30 multiplied by RW. And take moments anti-clockwise, and I know that this is mg, and again I'm going through an angle, so it's mg cos 60. So that's the force, and that's at a distance of exactly halfway because the weight acts at the centre of mass. So I know that that's going to be AB over 2 mg cos 60. Now, because this ladder is in equilibrium, it's not moving, I know that the clockwise and anti-clockwise moments, when taken around any point must be equal. That's the principle of moments. So I can use that fact to say that AB cos 30 times by RW is equal to AB over 2 mg cos 60. I can then rearrange this. Effectively, I'm going to divide through by AB cos 30 to leave me with RW on this side, and I can say that RW then is equal to, the AB's cancel out, and this is then going to read mg cos 60 all over 2 cos 30. Now, I'm going to put that in my calculator. I know all of those values now. So I know that m is 20 kilograms. I'm going to press my fraction button because this is a fraction. That's the best way to do this. So I know that's 20. I'm going to put in my g, my fancy calculator. I'm going to then say cos 60 and come down to cos 30. Press equals. And I'm going to say that is 56.62 newtons. Now, I've been given only two significant figures here, so I'm going to write this in my answer as 57 newtons to 2 sig fig. Okay. Now, next thing I'm going to do is find Rg. Now, this is actually far easier than it looks. Because again, this body is in equilibrium, the vertical forces must balance. It's not falling through the floor and it's not taking up off the ground. The only vertical downwards force is mg. So I know that Rg must equal mg. So the reaction force from the ground must equal the mass times the gravitational field strength. So I can say that Rg is equal to mg, which equals 20 times 9.81 newtons. So again, pull this out and I'll just do 20 shift 7 and g, and that is 196 newtons. So I'm going to round that up to 2 sig fig, so it goes up to 200 newtons to 2 sig fig. Now that means now that I can solve for p. I know everything else, so that means that I can solve for p. And to do that, I'm going to now take moments around A. So that means that I can ignore RW. So I'm going to see how this thing is pivoting around A. In order to do that, I have to resolve my forces again. So I have to look at Rg at 90 degrees, which I have to resolve Rg to 90 degrees, and I also have to resolve the force P to 90 degrees. So, if this angle is 60, this one must be 30 to make up 90. And if that angle there is also 90, which it has to be in order for me to resolve it, I know that that angle there is also 60 degrees. And if this angle here is 60 degrees, is 90 degrees even, that one's 60, that makes this angle there 30 degrees. So, I am going to look at taking moments around A. Okay, so I'm going to look at clockwise first of all. Now I've got both mg and p pointing clockwise. So that is going to equal AB over 2 mg cos 60. Same as before, it's half the distance of the whole thing and cos 60 to make it perpendicular. I'm going to have to add on p cos 30. Multiplied by AB, because that's now the full length. And I know anti-clockwise moments are going to be, that's going to be AB. This is RG cos 60. However, I know that RG is equal to MG. So I'm just going to do MG cos 60 in there. I can make that straight away. I know that these two must be equal to each other. So I can write AB over 2 mg cos 60 plus AB p cos 30 is going to equal AB mg cos 60. So that's just writing all of that out, substituting in for the fact that the clockwise moments are equal to the anti-clockwise moments. Now I've got that half AB mg cos 60 is equal to AB mg cos 60. So I'm just going to take this one away from that one. So I now can say therefore AB p cos 30 is equal, and a whole one, take away a half of one, leaves a half one, is equal to AB mg cos 60 all over 2. I can divide through by AB and divide through by cos 30 to say that P is going to equal mg cos 60 all over 2 cos 30. Which, if we've looked at it, we've got the exact same thing here. So I know that's going to equal 57 newtons to 2 stick figure. And that's how we do that.